Good day, everyone. Today, let's learn about the addition of vectors. There are two terms that we need to differentiate. We have scalar quantity and vector quantity. Now, scalar quantity describes or is described only by the magnitude, and vector quantity is described by both magnitude and direction. Okay, let's say you are going to a body of water or in that direction from a house. You could travel through different paths coming from the house going to that direction. So example of a scalar quantity is the total distance covered through path 1 and path 2, while the vector quantity here for this example is the displacement, which is the shortcut distance from the house going to that direction. So if you indicate the direction with the magnitude, let's say 5 kilometers, then we're referring to a vector quantity. If we just calculate the distance going to that direction, irregardless of the direction, then it's an example of a scalar quantity. So let's classify the following into scalar or vector quantities. Force. Okay, is it a scalar or vector quantity? Obviously, it's a vector quantity. Temperature is a scalar quantity. Time is scalar. Displacement is a vector quantity. Mass is scalar. Velocity is vector quantity. And energy is scalar quantity. So how do we represent vectors? We usually represent vectors through an arrow pointing in the direction of the displacement. Let's say the vector quantity we're referring to is the displacement. So from the starting position, p sub 1, okay, and to the ending position, p sub 2. And you will see an arrowhead going to the destination, and from the starting position is represented by a tail. And we usually write the vector quantity with a letter, okay, bold italicized with an arrowhead on top. So this is the handwritten notation of the vector representing this displacement. So how do we add parallel vectors? Okay, to add them, we have to know what parallel vectors are. Parallel vectors are vectors that have the same direction. Equal vectors are vectors that have the same magnitude and direction, while negative vectors are vectors that have opposite direction. So let's say for this example, p sub 1 to p sub 2 and p sub 3 to p sub 4, both of them are heading towards the same direction, therefore they are parallel. If they have the same magnitude, then they are considered equal vectors. While the other one, p sub 5 to p sub 6, is heading towards the opposite direction, opposing the direction of the first two vectors. Therefore, this is a negative vector. As you can see, it's a vector b equals the negative of the vector a. It's opposing the previous vector. So here are examples I've taken from physics classroom. So as you can see in the first example, we have two vectors heading towards the same direction with magnitude both are 5. So the total distance or displacement rather is 10. Okay, let's say the quantity is displacement. So if we just represent them through arrows, then we could use other quantities for that. So for the first arrow in the second example, we have 5 going to the east, and then the next one is negative 5 because the arrow is heading towards the opposite direction, and the net is 0. Third example, we have 5 heading towards the east and 10 heading towards the east as well, but then you will notice that the length of the magnitude for 10 or the arrow is longer compared to 5 because the length of the arrow represents the magnitude of the certain quantity. If it's bigger, then the arrow should be longer. So 5 plus 10 equals 15. Next example, we have 5 heading towards the east and 10 heading towards the west. So we have to subtract the values to get this difference, which is negative 5. For the next example, so 5 added to another vector quantity which is opposing in direction. 15 is the magnitude, so 5 minus 15 is negative 10. And lastly, for example, is 10 heading northwards and negative 5 southward. Since they're opposing, then we have to subtract the values. 10 minus 5 equals So that's how we're going to add parallel vectors. How about if we are going to graphically add vectors? So we have many methods, but I will be emphasizing in this video about the head to tail method. So here's the first example for two vectors, 11 units south and 6 units west. So before we add them, we have to be familiar with the coordinate system. So this is the Cartesian plane with 4 quadrants. The first quadrant is present on this side. It's here with positive x and positive y. The next quadrant, quadrant 2, is located in the negative x and positive y. Quadrant 3 is located in this side with negative x and y, negative y. And the fourth quadrant is having positive x and negative y. So how do we represent that in a graph? So make sure you scale first. Okay, given 11 units, you cannot represent everything if it cannot fit in our paper. So make sure you scale or provide a legend. So for 1 unit in this example, it's equivalent to 0.5 centimeters. Let's say we already had 11 units south and represented by a vector A. That's 11 units. And then 6 units to the west. Now, what arrow represents the sum of these vectors? This is actually the red arrow represents the sum of the two vectors, and we call that the resultant vector. Resultant vector forming an angle, okay, from the origin. So using Pythagorean theorem or theory, okay, we can actually calculate the resultant by getting the square root of the square, sum of the squares of the sides. So that's 6 squared, that's the side for the B vector, and 11 squared for the length of the vector A. So 6 squared plus 11 squared, square root of that is 12.53 units. And that's our resultant for this example. And in getting the angle, you just have to get the arc tangent or shift tangent in your calculator by dividing 6 and 11. So 6 divided by 11, get the arc tangent, then you will get the angle 28.61 degrees. So in doing such, we have identified our resultant and its location. So 12.53 units, 28.61 or 29 degrees west of south. Now here's another example. Let's say you have already scaled that in your graphing paper. In my case, I would like to have it as 100 unit per 0.5 centimeter. So it's heading westward, 500 units represented by vector A, or that A letter as our first vector. And the other one, okay, after that motion, it headed rather to the north with 400 units represented by vector B. Of course, our resultant is okay, the head of that resultant is touching the head of the second vector. So why is it called the head to tail method? Because the head of the first vector, okay, points to the tail of the next vector, and the resultant vector is actually pointing to the head of the last vector. Okay, so how do you compute for the R? You just have to square 400 and 500, square root the answer, and you will get 640.31 units. And the location, divide 400 with 500 and get the arc tangent. And the result is 38.66 degrees. So the final answer is 640.31 units, 38.66 or 39 degrees north of west. Okay. For our next example, you may do this also, or you may pause the video and do this in your graphing paper. Okay, once you're finished, now let's show the answer. So 7.5 units north. Let's say you have scaled in a graphing paper, 1 unit is 2.5 cm. That's our vector A, or the first vector. Now the next vector is heading to the east. As you will notice, the head of the first vector touches the tail of the next vector. To represent our resultant vector, then you will notice here an arrow with an arrowhead touching the arrowhead of the last vector, or the second vector. So how do you compute that? Get the squares, or the sum of the squares of the sides, 3.5 and 7.5. Get the square root and you will arrive to this answer, 8.28 units. And to get the angle, then you have to get the quotient of 3.5 and 7.5. Get the arctangent and you will see the answer, 25.02 degrees. And our final answer is 8.28 units, 25.02 degrees east of north. Now for our last example, you have here 7 units east and 12 units south. So let's represent that with an arrow in our first vector, and the second vector is 12 units south. Okay, represented by vector B. Okay, to represent our resultant vector, then you will notice here a red arrow pointing to the arrowhead of the last vector. Okay, using Pythagorean theorem, you will just square or sum of the squares of the sides, 7 squared and 12 squared, get a square root, and you will have this result, 13.89 units. To get the angle, have the quotient of 7 and 12, get the arctangent in your calculator, and you will see the answer, 30.26 or 30 degrees. Now the problem here is the location. Yeah, that's the answer, but you can just flip it if you are confused. Okay, you can flip it, okay, to get the answer. So I cannot anymore move backwards with this application. So that was the answer for the previous example. So let's review about the different angles. Okay, let's take note that if you notice this, okay, the angle is formed between this arrow, or the given arrow, and the positive x-axis. Then you call that the north of east. If it's formed between the positive y and with your arrow, then we call that the east of north. If it's formed between the negative x and that arrow, then it's called the north of west. If it's formed between the positive y and that arrow, west of north, and so on. So if it's formed below the negative x, that is the south of west. If it's there, then west of south, formed between the negative y and that arrow, negative y and this arrow, between them is an angle. Okay, east of south, and lastly, okay, just below the positive x, but located near negative y, then that's the south of east. So you have to be familiar with all those so that you know how to express the final answer when you're asked of the location of a certain vector, especially the resultant. So here's an example for 3 vectors. Let's say, okay, vector A is 25 meters, 49 degrees north of east. So of course you know that north of east is in the side. So you have to use the protractor to identify 49 degrees. So when you're done using your protractor, then you measure 25 meter using a scale. Let's say your 1 meter is 0.5 centimeter in your graph. So you will have this kind of answer. So that's our vector A, 25 meter, 49 degrees from the x-axis. And then the next part, okay, to represent our vector B, you may represent another Cartesian plane here at the arrowhead of the first vector, touching the tail of the next vector. And you will notice here that it's 15 degrees north of east. So from the horizontal line, 15 degrees coming from positive x, okay, that side, and you draw after identifying the angle. So that's our letter B, or vector B. Our vector C, obviously, you have to draw that by identifying first where to draw the next Cartesian plane, small Cartesian plane. Of course, it's in the arrowhead of the second vector. There. And then use a protractor to identify 68 degrees south of east. Now 68 degrees south of east is here on the fourth quadrant. Once you're done measuring the angle, then you start drawing the arrow downwards that exceeds the horizontal or x-axis. Of course, how are you going to identify the resultant? It's by drawing an arrow from the origin going to the last or the arrowhead of the last vector. Okay, that one. So you can do that by measuring this with your ruler and identifying the angle between the x and this arrow resultant using a protractor. Okay, the answer to that is 50 meters, 7 degrees south of the east. Okay, here's another example. 5 kilometers west, so it's already drawn, 5 kilometer west. Okay, there's no angle, therefore it should be along the x-axis. Then after moving in such manner, it has moved also, or the next vector is heading northward. Okay, with no angle or no inclination, so it's northward. And the next vector is actually connected to our second vector, so you have to represent another Cartesian plane so that you will know where to measure using your protractor. So what's 345 degrees? Take note, in the first quadrant is 90, second quadrant has also 90, all in all that's 180. And for the third, 180 plus 90, we have 270. And of course, the entire thing is 360 degrees. So you will locate 345 degrees in the fourth quadrant because it's close to 360 degrees. So you will notice here that the arrow has been drawn in the fourth quadrant. Okay, with this length 3.5 kilometers. Now, to draw the resultant coming from the origin going to the head or arrowhead of the last vector. So when measured, that's 2.3 kilometers, 135 degrees CCW. CCW stands for counterclockwise. So meaning the angle is measured from the positive x going to that location. Okay, so let's review on unit circle because you've noticed I have mentioned counterclockwise and clockwise. So this is what I'm talking about. I've already mentioned about the quadrants 1, 2, 3, and 4. In the first quadrant, we have a 90 degrees in total from the x, positive x, going to the positive y. Next, of course, is another 90 in the negative x and positive y. So all in all, on the upper part, we have 180 degrees. And let's add another 90. Okay, in the lower part in the third quadrant, so 90 plus 180 results to 270 degrees. And lastly, we have 360. Okay, now if there's an arrow drawn in that location, it intersects, okay, that circle at one point. So it has an x component and a y component. So you have to review your trigonometric discussions before about unit circle, okay, if you want to learn more about this. Okay, and also we have to review about the trigonometric functions, especially the definition of SOHCAHTOA. So SOH, sine theta, is equal to the opposite over the hypotenuse of the angle. So this is only true for a right triangle. So this is the right triangle with 90 degrees and angle is here. Okay, so opposite over the hypotenuse. That's the sine theta. Cosine theta is adjacent of that angle divided by the hypotenuse of the triangle. Tangent theta is the opposite of the angle divided by the adjacent leg or adjacent leg of that angle. So that's TOA. So that's how we define SOHCAHTOA. Next, so vector addition using analytical method. Lately, we have measured using the graph or the head-to-tail method, although meron pang iba, just like parallelogram method. So this case, let's identify the component of a certain vector A in this example. So to get the x component, you have to use the SOHCAHTOA definition of an angle. Take note, cosine theta is equal to the adjacent over the hypotenuse, the adjacent leg over the hypotenuse. So when you want to get only the x component of the vector, then you just have to multiply a with the cosine theta. Okay, same is true with the sine theta, the y component divided by the vector a. So y component of the vector is equal to a, or the magnitude of the vector a multiplied to sine theta. So let's have an example. Let's say an airplane is to be launched. It's about to depart. Now it's moving at a velocity of 40 meters per second at an angle 15 degrees from the positive x-axis. So how are we going to get the x component of the vector 40 meters per second? So to do that, you just have to multiply 40, which is the magnitude or the velocity of the airplane, multiply to the cosine of 15 degrees. So the result is 38.64 meters per second. That's the x component. How about the y component? So the same thing, 40 multiplied to the sine of 15, that's 10.35 meter per second. How about if, in this example, Superman is moving at the fourth quadrant, no longer in the first quadrant? Of course, we have to use the unit circle to identify the angle from the x-axis. To do that, of course, you have to imagine you have encircled that. The entire thing is 360 degrees minus 30, that's 330 degrees. That's the angle that we're going to use when computing for the x component and y component of the vector. To do that, so 100 multiplied to the cosine of 330, which is the angle from the x-axis, the answer is 86.60 meters. And the y component is 40. Okay, so it's not 40, it should be 100. Okay, I would like to correct that. So 100 times sine of 330. Okay, the answer to that is negative 50, not negative 20. So this is incorrect. That should be negative 50. Okay, so let's have an exercise. So let's say in this part for vector A, it's 28 degrees from the x-axis. To get the x component, just multiply 15 with cosine 28. The result is 13.24 meters. Get the y component, that's 15 multiplied to the sine of 28, that's 7.04 meters. Next, for vector B, take note we are measuring from the positive x. Since the angle between the y-axis and the vector B is 30 and the total angle for quadrant 1 is 90, we have to use the difference of 90 and 30, which is 60. So 20 times cosine 60 is 10 meters. 20 times sine 60 is 17.32 meters. So there's no second, it's just meters. Next. Okay, so the angle is already measured from the x-axis. Therefore, we just have to multiply 18 with cosine 124, which is negative 10.07 meters. And lastly, okay, the given angle is 39 degrees. Take note, we're going to measure from the positive x-axis. So 90 plus 39, that is 129 degrees. So 25 times cosine 129 degrees is negative 15.73 meters, and dy, or the y component of this vector, is 25 times sine of 129 degrees. That is 19.43 meters. Okay, that's it for the components. How about if we are asked about the total or the resultant when added? Okay, so let's use or calculate them through these examples. Okay, a hiker is walking through the woods. He starts from his campsite, which is its origin. He initially travels along the x-axis, and his initial displacement of 1,200 meters takes him to the tip of vector A. Hence, A has a length of 1,200 meters and it's parallel to the x direction. He then turns and moves along the path described by vector B. This vector has a length of 1,500 meters and makes an angle of theta B equals 30 degrees with the x-axis. When the hiker stops, how far is he from the campsite? So we will represent this vector through this. So vector A, vector B, and this is the resultant vector. And vector B is forming 30 degrees from the positive x-axis. Now, how to solve for the resultant of each component? So let's get the x component or horizontal. X represents horizontal, y represents vertical component. So for vector A, which is this arrow, 1,200, okay, is the answer because cosine of 0, let's check, cosine of 0 is 1. So 1 times 1,200 is 1,200 meters. And then the y component is 0 because the sine of 0 is 0 multiplied to 1,200 is 0. Next, for letter B, let's multiply 1,500 with the cosine of 30. Okay, the answer is 1,299.04. Then let's do the same this time with the y component, 1,500 multiplied to the sine of 30. The answer is 750. To get the r, or resultant, we just have to add, okay, the entries for the x component. Okay, sum is 2,499.04, and the sum of the y components, that is 750. Okay, take note, we always have to use the correct angles so that we can arrive to the correct answer. So to get the resultant, we have to get the square root of the sum of the squares of the components. So that's 2,499.04 squared added to 750 squared. Get the square root of the sum of the squares. The answer is 2,609.16 meters. To get the angle formed from the origin or from the x-axis, okay, you just have to get the arctangent of the quotient of the y and x component. So divide 750 with the x component, 2,499.04. Get the arctangent, and the answer is 16.71 degrees. So resultant is 2,609 meters, 16 or 17 degrees. That is north of east. Next example. 3 players on a reality TV show are brought to the center of a large flat field. Each is given a meter stick, a compass, a calculator, a shovel, and the following displacements. A, 72.4 meter, 32 degrees east of north. B, 57.3 meters, 36 degrees south of west. And letter C, 17.8 meter due south. The 3 displacements led to the point in a field where the keys to a new porch are buried. 2 players start measuring immediately, but the winner first calculates where to go. What does he or she calculate? The first thing that you have to do is understand the problem. Second thing is to graph or represent the vectors in the problem. And when you are done representing that, it will look like this. So let's discuss this part by part. The first given is 72.4 meters, represented by vector A, forming 32 degrees east of north. So this is east of north, 32 degrees. Next, 57.3 meters as letter B. So we have to hypothetically make a Cartesian plane on top and locate 36 degrees south of west. That's located in the third quadrant. So dito po yung third quadrant. So 57.3 meters. And letter C is 17.8 meter due south. So it's not inclined. It's vertically ganito lang siya along parallel with the y-axis. So how are we going to calculate or answer what is being asked in this problem? So you have to get the x components of each vector and the y components to get the resultant vector components. So let's recall, the first one is cosine 58. The given there is 32 degrees, but that was formed east of north. Take note, we are always measuring from the positive x. So 90 minus 32 is 58 degrees. Therefore, in vector A we are going to use 58 degrees in our calculations. So the x component of vector A is 72.4 multiplied to cosine of 58. The answer is 38.37 meters. Okay, for the y component, 72.4 multiplied to the sine of 58, the answer is 61.40 meters. And then for b sub x, 57.3 times cosine of 216. Okay, we get this value, which is negative 46.36 meters. Okay, likewise with the y component. And letter C, okay, it's only vertical component, therefore x component is 0 and y component is the sine of 270, which is negative 1 multiplied to 17.8, negative 17.8 meters. Let's sum up all the answers in x components from A to C. That's the answer, negative 7.99 meters. And sum up all the answers in the y components. That's 9.92 meters. To get the resultant value of the entire thing, so r equals 7.99 squared. Of course, the square of a negative number is an absolute value of the number. Plus the 9.92 squared. Square root of the answer is 12.74 meters. Get the angle by dividing the y component with the x component. 9.92 divided by negative 7.99. The answer is negative 51.15 degrees. Okay, take note, the negative 51.15 degrees is formed from the negative x-axis. Okay, we are trying to solve the angle from the positive x. So if we are going to view only the angle or use the angle from the positive y, then the answer is 39 because 90 minus 51 is 39 degrees. But if you want to measure from the positive degree or positive x-axis rather, so 39 plus 90 is equivalent to 129 degree. Therefore, the answer could be 12.74 meters, 39 degrees west of north, or 12.74 meters, 129 degrees, okay, north of east. Okay, so that will be the answer. Okay, and for the last problem, a GPS receiver told you that your home was 15 kilometers at a direction of 40 degree north of west, but the only path led directly north. If you took that path and walked 10 kilometers, how far and in what direction would you then have to walk to reach your home? The resultant is already given, and the answer is 15 kilometers. Unlike the previous problems, okay, resultant is being calculated. In this case, resultant is already given, and we are trying to find the vector b. So to do that, we just have to get the components. So here are the components of the vectors. We have calculated the a and the r, which is 140 degrees. So to get the components of the b vector, just have to subtract. So negative 11.49 okay, is 11.49 kilometers. And in this case, that's 0.36 kilometers. So that's it for today, and here are my references. God bless, and see you again next session.